So before I was talking about the impeller on this new toilet, I want to go over a little bit design ideas for it and various types of pumps. There are many types of pumps, and I want to show you a couple of types. So here is types, and you can see that the efficiency does vary. You see the most efficient pumps are in the 90% efficient, and least efficient pumps are in the upper 85%. This may not seem like the world's biggest deal, but there's about 10% energy saving. And that with these between the types. Now we can't actually use the most efficient here, the piston pumps, and those are pumps that have a piston that first goes down and sucks in water or something, then compresses it by pushing up and lets it out through a valve. Gear pumps, on the other hand, have actual gears in them that turn around and move a certain amount of water with different motions. So I will show you some pictures of different gear pumps. This is an external gear pump, which is not the best name in my opinion, but it has two gears in it that interlock. And this interlocking causes it to first, when the spinning, water gets into this little cavity that gets forced into a small cavity and pushed out into a bigger area. So these two interlocking ones cause a pressure differential that pushes out the water over and under the top. So over the top gear, under one volume, by squeezing it and forcing it in a certain direction. Besides, this also applying some momentum. So not only you're applying momentum, you're forcing it. A centrifugal pump. Then the other type of gear pump, sorry, that was external. Internal, instead only just has one gear that is really moving around inside pockets that it hits, like here. This is one that's actually useful to see the diagrams. So now to show you how an internal gear pump works better, and sometimes it has this question thing, sometimes it doesn't. Is let's see, where's a nice diagram of it, but it moves at right angles. I'm gonna now just zoom a lot, or so water first comes in one of the exits, and the gear then moves and compresses it in the little stalks here. But then water doesn't like to be compressed, so it moves outwards into the next section, then moves outwards into the next section, and the next section it gets compressed to push it out from the top as this gear moves. There's a better diagram here. We see the water comes into one of these little holes. When the gear hits it, it compresses it and pushes it out, and pushes out along the whole thing. Kind of like a piston pump, but instead of a piston, we have the gears compressing it. The other type that I didn't show you, that's not piston, is centrifugal pump. And centrifugal pump works by having a propeller that spins it, and it uses centrifugal force. So when the water hits it, it pushes the water to outside, to the ends of the propeller, which compresses it. Then you have a duct or something to redirect that water along a certain direction, either at 90 degrees, like here, or it's a skinnier thing. The last type of fan, which is by far the least efficient, like half of the one compared to other ones, The centrifugal pump is a lot less efficient than gear pumps. Is a regular propeller or something you see on planes and stuff. But there's reasons why we use it on planes and stuff, because they work better at really high speeds and stuff. It's more durable and it can push more stuff through it at once. So we have all these different types of pumps. And I think a gear pump would be an excellent use for here and would save a lot of energy compared to normal pumps. Because a gear pump can, with its compressor and stuff, really chop up things and cut it down. And it can also work better in high viscosity. There's a bunch of different types of gear pumps, but there's internal and external, there's real combinations. We can choose one particular one. But how much more efficient can this be compared to a normal centrifugal pump and a normal and other normal pumps? Well, centrifugal pump, here looking at efficiency, which is really hard to see this line. Maximum efficiency of a centrifugal pump is 70%. But it can drop as low as 55 if it's slightly less than optimal conditions to 40%, depending on what's end. Well, my pump that I'm saying, gear pumps, which we call positive ones, there's a whole bunch of positive ones. Those are all the ones that compress fluid in alternating ways and then push it out, is always between around 75 to 90% compared to you ask which types. The same thing is efficiency for viscosity. And more viscous material would be material more ground out solids and stuff like that. So positive can handle more ground up solids a lot better. By a high viscosities, it's almost twice as amount efficient. So this grinding action could be really built in and make it efficient under a variety of conditions, and much more efficient than a trash compacting mechanisms normally, because trash compacting normally has many problems in that it makes it harder for microbes and stuff to get to the material. It takes a lot of energy to compact stuff compared to chopping it up and mixing it. The water helps break stuff apart more easily, and it has lubrication, so it's not solid stuff. It stops sparks and all these other things. So I think this will be one of the ideal pumps. Now you would have to make a lot of, once we have this whole group, we can split up into internal and external gear pumps and all little varieties, and we start simulating it for a wide range of conditions and figuring out what's the best usage. Here we get into a little second problem, because the best design really depends on how much people are going to use it for different things, which might evolve with times as people start falling down different things or using it differently. So what types would it would be best if we could collect data. Now, having tools that collect data, you might say, is also an invasion of privacy, which is a fair point. Or you would have to have labs that collect data about how people use it in a lab with special signs saying, can we collect your data? Or this lab is for collecting data. Or you just have to take a guess for a good one that's good all around. Another thing about grinding up stuff that I just thought of that can make it better is that if you had something to analyze the waste, you might get some better indication of someone's health from stuff containing the poop or something like that that's more easily appeared when it's ground up and fine. So it might lead to better analysis that way, or further down the line, better analysis for like if you're trying to read viral DNA and stuff like that, which is actually a reason why you might not want to over sanitize it with ozone and stuff beforehand, so you can read measurements of disease outbreaks better. I don't know how relevant that is, but it's an interesting idea. Now this might lead to toilets because of the design getting bigger, because gear pumps do take up more space. Not a lot more space, but it would be it, which might lead to higher toilets. Now higher toilets have some advantages. For some people have a really hard time squatting because of physical disability problems, so there is that advantage. It might hurt some other people. Some people say it's more comfortable not in the squatting low toilets. I don't know if it's also hurt some other people that are disabled in other ways, but I'm just saying, for some people, higher toilets are better. Please correct me if I'm wrong. Now, that all being said, I don't think this is the end of the discussion, and I would like to hear about other ideas. Maybe having multiple gears, you could have it even more efficient pump designs that could grind up something better. But then you have to do really complex calculations because there's gear pumps that are a combination of internal and external. There's vane pumps, which I didn't talk about, with vanes that change shape and directions, but that requires flexible material, which I don't think is a good idea with flexible material, because flexible material could worse break than a solid propeller. Which now, and stuff like that. And we can also have more efficient other things with maybe now redesigning the pumps, the actual plumbing within the toilet with all the different gaps going in, up and down and stuff, to make the flow better with the propeller, because the propeller adds a new dimension to the flow. It adds a dimension to the flow where the flow is not as dependent on, has a boost. So that boost in cavitation, where water is being sucked in and forced through different gaps, and they might have air getting trapped and cavitated if it's too fast in one section or not. So you might have to also redesign the whole toilet to use this with energy efficiency. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think can do it. Also, if you have any ideas for future videos, comments or suggestions, please leave them in the comment section below. Again, thank you very much. Goodbye.